You can go a month without food, but without water, you'd be gone in just 3 days. In fact, your body is slowly dehydrating right now as I speak. So here is the real question. Do you actually understand what is happening inside your biological machinery when you drink water? Or worse, do you know exactly what happens to your cells when you don't? Most people know they should drink water, but very few understand why it is so critical. How does your brain monitor every single drop? What does your body actually do with the liquid once you swallow it? And what is really happening to your organs when the tank runs dry? Today, we are going deep into the human body to explore the fascinating science of survival. We'll look at real human anatomy to understand how water moves through your system, how your brain serves as a command center for hydration, and the terrifying reality of what happens when things go wrong. Trust me, by the end of this video, you will never look at a glass of water the same way again. Let's start with a fundamental truth. Thirst isn't just your body asking politely for a drink. It is a survival alarm system. Without water, depending on your environment, you could die within days. In the blazing heat of a desert, it happens even faster. Compare that to food, where humans can survive weeks or even months without eating. Water isn't optional, it is essential. But here's something most people don't realize. Your body stores water in 2 completely different places. About 2/3 of your total water volume lives inside your cells. We call this the intracellular space. This is the water inside the cells of your brain, heart, lungs, kidneys, and every other organ. The remaining 1/3 exists outside your cells in the extracellular space, like in your connective tissues and your blood. This distinction matters because you can actually experience 2 different types of thirst. If your cells become dehydrated, drinking plain water usually does the trick. But if you lose blood, which contains both water and electrolytes, you need more than just water. You need salt too. This is why sometimes after intense exercise or heavy sweating, drinking plain water doesn't quite satisfy you. Your body is asking for the electrolytes you lost. Now, you're probably wondering how much water you should drink each day. The answer is more complicated than you might think. It depends on numerous factors: your altitude, your age, your activity level, whether you drink alcohol, and even your biological makeup. But here is my honest advice. Don't get overwhelmed by the numbers. Start by building the habit of drinking water regularly. Then, fine-tune the amount based on how your body responds. Pay attention to your thirst signals, check your urine color, and adjust accordingly. This approach works for most health improvements. First, understand why something matters. Second, build the habit. Third, optimize over time. Now, let's get into the mechanics. Imagine looking at a cross-section of the human head, cut directly down the middle. Deep inside the brain, there is a small region called the hypothalamus. Just below it is an equally fascinating structure called the pituitary gland. Together, these 2 form a critical bridge between your nervous system and your hormonal system. The hypothalamus communicates constantly with the pituitary gland, which then sends signals throughout your body. Most of these messages revolve around homeostasis, which is just a fancy word for your body's natural state of balance. The hypothalamus works tirelessly to maintain this balance. Think about your body temperature. When you get too hot, your hypothalamus detects the temperature rise and initiates sweating to cool you down. When you're cold, it triggers shivering to warm you up. Water regulation works similarly, though we use a more specific term called osmoregulation. To understand this, we need to talk about osmosis, which is the movement of water from one area to another based on electrolyte concentration. You've heard of electrolytes. They're in sports drinks and energy beverages. These include sodium, chloride, and potassium. They are found throughout your body and are absolutely essential for cellular function. Inside the hypothalamus, there are specialized cells called osmoreceptors. These are stretch-sensitive neurons that can determine your body's overall water and electrolyte levels by measuring what is inside themselves. It's brilliant when you think about it. When you don't have enough water, these osmoreceptors shrink. This shrinkage sends a signal to the posterior pituitary, telling it to secrete a hormone called antidiuretic hormone, or ADH. The name tells you exactly what it does. A diuretic makes you urinate, so an antidiuretic hormone prevents urination, helping you retain water. When you're dehydrated, it makes perfect sense for your body to hold on to every drop. On the flip side, when you have too much water, those osmoreceptors swell up. This triggers the opposite response. Your body produces less ADH, which means more urination and water loss. Everything comes back to balance. But osmoreceptors aren't working alone. They are part of a larger regulatory system. Another example is baroreceptors, located in your blood vessels, especially in major arteries like the aorta coming out of your heart. These monitor blood pressure. Here's why that matters. Blood contains water. Too much water in your bloodstream elevates blood pressure. The baroreceptors detect this stretch and initiate events to regulate it. If you get cut and start bleeding, you lose water, blood pressure drops, and those same baroreceptors sense the change and respond accordingly. It's all connected. Now let's look at the kidneys, the ultimate filtration system. The kidney filters blood with incredible precision using millions of microscopic units called nephrons. The newly filtered blood travels back to your body, while the waste products drop into the inner core of the kidney to be sent to your bladder. Here's the fascinating part about the kidneys. The kidney tissue itself is naturally salty, loaded with sodium and chloride. This salt attracts water like a magnet. When you have too much water, the kidney moves salt into the collection tubes, which draws water with it. That water becomes urine, and you eliminate the excess. When you're dehydrated, the salt moves more into the kidney tissue, pulling water along with it. This water gets reabsorbed into your blood vessels and returned to your body. All of this happens automatically without you even thinking about it. So what actually happens during dehydration? It depends on the type. Blood loss is technically a form of dehydration, and severe blood loss creates immediate life-threatening problems. But there are other ways to lose water beyond urination. You lose water through breathing, speaking, crying, and sweating. And you're not just losing water in these processes, you're losing electrolytes too. Those salts attract water, so to eliminate water, your body must also eliminate some electrolytes. This affects the entire pathway. The severity depends on what you're losing. Is it just water? Is it just electrolytes? Or is it both? And in what amounts? Ultimately, dehydration affects your cells, the fundamental units of your body. Common symptoms include headaches, dry mouth, dry lips and eyes, and darker urine. The darker color comes from higher concentrations of waste products in less water. You'll experience confusion, fatigue, and as dehydration worsens, these symptoms intensify. In late-stage dehydration, confusion becomes delirium, potentially even leading to psychotic episodes. Essentially, you're dying slowly at first, then rapidly as dehydration progresses. It's a harsh reality, but understanding it emphasizes why water is so critical. Water isn't just another health trend or dietary recommendation. It is the foundation of every single process happening in your body right now. Your osmoreceptors are monitoring your hydration status, your kidneys are filtering and regulating, and your cells are depending on the perfect balance to function. So here is what I want you to take away. Hydration isn't just about drinking 8 glasses of water a day. It is about understanding your body's signals, replenishing both water and electrolytes, and building sustainable habits that keep your system in balance. If you found this deep dive into human anatomy valuable, hit that like button and subscribe for more science-based explanations of how your body actually works. Drop a comment below and let me know what topic you want me to break down next. Now go grab some water, maybe add a pinch of salt, and keep that incredible biological machine of yours running optimally. I'll see you in the next one.